Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw an actual calculation of the beta IV using the following model. We only used the first stage from the IV and also the reduced form in order to get to our beta IV. And one of the things, the key takeaways for that video was also that this beta IV was giving us the comparison of people whose education differs because of how far they live from uni, because the distance from uni was our instrumental variable. So one of the most common questions that would come as a follow-up would be, well, where did OLS actually go wrong when we use that? So why or when did OLS go wrong? The thing is, OLS uses all the variation in education, both clean and contaminated, which means that you will have ability, which brings higher ability, equal to more education, which means also higher earnings. You could have also motivation that gives you exactly the same kind of channel, more motivation, more education, higher earnings, which means that overall you have reverse causality as well, because expected higher earnings means that you also get more education, okay? Instead, what IV does, so again, here, all variation in education, clean and contaminated. Okay. Instead, what IV does is it uses only the variation in education coming from distance. Okay. So the variation is plausibly clean. Distance is unlikely to be correlated with ability or motivation. And IV strips away basically the contamination that OLS unfortunately cannot. So normally you would have a diagram which we've been using quite a lot in this mini series for the IV, is that distance is affecting education, and then education affects earnings. Okay. So if we go back to the results that we had from the numerical example, what we have is that we would have from stage 1, okay, distance explaining education. So here we would have that pi1 equals to minus 0.2. Then stage 2, okay, which would have been the predicted education explaining earnings. Then that beta, which would have been the beta IV, would have been 3. Okay, and the reduced form, which combines both, would have been that sigma 1 minus 0.6. Okay, so the reduced form, a reminder again, so there's 2 ways to look at the exercise, either from the previous video where we get stage 1 and the reduced form and we found the IV, but we could have stage 1 and stage 2, and from there we can easily find the reduced form, which is the product of these 2 stages. So sigma 1 hat is your pi 1 hat times your beta 1 hat IV, which would have been minus 0.2 times 3 minus 0.6, okay? So, and always try to verify this identity, because if this is not correct in your own calculations, it means that something has gone wrong, okay? Now, there is one important clarification that I want to bring here, because students often say the instrument estimates the effect of education. So the instrument estimates the effect of education, okay? Now, the instrument does not estimate anything directly, okay? So this is not the correct way of expressing it. What the instrument does is it creates clean variation in education, variation that is free from the endogeneity problem, okay? So then 2SLS uses that clean variation to estimate the causal effect. So the instrument is source of identification. 2SLS is the estimation procedure, and that's how you get to have your final results, which are causally interpreted if you have picked the right instrument, okay? Now, this is the most intuitive way to see also why the ratio works. Think of the instrument as giving basically education a small push. So 1 additional kilometer reduces education by 0.2 years, and that same push reduces then earnings by 600 pounds. So if 0.2 years of education correspond to 600 pounds of earnings, then it means that 1 full year of education, right, would correspond to 600 divided by 0.2, which would have given you that 3,000 pounds that you talked about earlier, okay? So you never directly manipulate education, you manipulate distance and then scale the earnings response by how much distance moved education, okay? And that's also at the core of the Wald estimator, and that's the IV. So this proportional reasoning works because we're assuming the only reason distance affects earnings is, again, through this channel that we mentioned right here, meaning education, okay? So that's the exclusion restriction, once again, made visible, but in an arithmetic way. So the IV estimate of 3,000 per year of education is recovered by scaling the instrument's effect on earnings by its effect on education, this little computation we just did here, which is ultimately just pure proportional reasoning. Now that you've seen IV estimation from start to finish, you've seen intuition, derivation, and a complete numerical example from both points of view, there still remains one important question to answer. Should we always prefer IV over OLS? And how do we formally test whether the difference between the two matters? That's exactly what we're going to tackle in the next video, OLS versus IV and the Hausman test. So stay tuned and I'll see you in the next video.